Hello everyone, the topic of today's lecture is Economic Evaluation of Mutually Exclusive Schemes with Unequal Lifespans in Construction Engineering Economics. For mutually exclusive schemes with equal lifespans, the lifespan of the schemes is usually set as a common analysis period to ensure time comparability when evaluating economic performance, using the principle of equivalent funds. When comparing mutually exclusive schemes with different lifespans, time comparability between the schemes is also required. Meeting this requirement involves addressing two issues. First, setting a reasonable common analysis period. Second, selecting a reasonable assumption for scheme continuation or residual value recovery. For schemes whose lifespan does not match the analysis period, commonly used methods include the net annual value (NAV) method and the net present value (NPV) method. Let's start by learning about the net annual value method. Meaning, the net annual value method primarily uses the net annual value index for scheme comparison. When the benefits of various schemes are difficult to measure or are the same, the annual cost index can also be used. In the net annual value method, the equivalent net annual value (NAV) or annual cost (AC) of the net cash flows for each alternative scheme is calculated and compared. Calculation formula: the formula for calculating NAV is the equivalent net annual value of the net cash flows for each alternative scheme. Evaluation criterion: the optimal scheme is the one with a net annual value greater than or equal to 0, and the highest net annual value, or the one with the lowest annual cost (AC). Using the annual value method to compare mutually exclusive schemes with different lifespans implicitly assumes that each alternative scheme can be repeated at the end of its lifespan using the original plan, or a plan with the same economic performance level as the original, because the annual value of a scheme remains unchanged, regardless of how many times it is repeated. The annual value method essentially assumes that each scheme can be repeated indefinitely. Under this assumption, the net annual value method compares the economic performance of each scheme on a per-year basis, making time-comparable comparisons possible between mutually exclusive schemes with different calculation periods. The net annual value method is the simplest method for evaluating mutually exclusive schemes with different lifespans, especially when there are numerous alternatives. Now, let's understand the net annual value method through two examples. Example 1, there are three mutually exclusive schemes, A, B, and C, with lifespans of 5, 7, and 8 years, respectively. The net cash flows for each scheme are as follows. Along with the benchmark discount rate of 12%. Please select the best investment scheme. Scheme A, initial investment of 1.5 million yuan, with a recovery of 450,000 yuan each year from year 1 to year 5. Scheme B, initial investment of 2 million yuan, with a recovery of 500,000 yuan each year from year 1 to year 7. Scheme C, initial investment of 3 million yuan, with a recovery of 550,000 yuan each year from year 1 to year 8. In this example, the lifespans of the schemes are all different, so we can use the net annual value method to compare and select the best scheme. Solution: calculate the net annual value (NAV) for each scheme. NAV sub A equals minus 150 multiplied by left parenthesis A over P, 12%, 5 right parenthesis, plus 45, equals 34,000 yuan. NAV sub B equals minus 200 multiplied by left parenthesis A over P, 12%, 7 right parenthesis, plus 50, equals 62,000 yuan. NAV sub C equals minus 300 multiplied by left parenthesis A over P, 12%, 8 right parenthesis, plus 55, equals minus 54,000 yuan. Since NAV sub A is greater than 0, NPV sub B is greater than 0, NPV sub C is less than 0. Scheme C should be eliminated. And since NAV sub B is greater than NPV sub A, Scheme B is the optimal choice. Example 2, mutually exclusive schemes A and B have the same output. Scheme A has a lifespan of 10 years, while Scheme B has a lifespan of 15 years. The net cash flows for both schemes are given in the table below. I sub C equals 10%. Please select the best scheme. Scheme A, initial investment of 1 million yuan, with expenses of 1 million yuan in the first year, and 600,000 yuan from the second to the 10th year. Scheme B, initial investment of 1 million yuan, with expenses of 1.4 million yuan in the first year, 400,000 yuan from the second to the 10th year, and 400,000 yuan from the 11th to the 15th year. In this example, both schemes involve expenses, and their lifespans are different. Therefore, we can use the annual cost method for comparison. Solution: calculate the annual cost AC for each scheme. AC sub A equals 100 plus 100 multiplied by left parenthesis P over F, 10%, 1 right parenthesis, plus 60 multiplied by left parenthesis P over A, 10%, 9 right parenthesis, multiplied by left parenthesis P over F, 10%, 1 right parenthesis, and multiplied by left parenthesis A over P, 10%, 10 right parenthesis, equals 822,000 yuan. AC sub B equals 100 plus 140 multiplied by left parenthesis P over F, 10%, 1 right parenthesis, plus 40 multiplied by left parenthesis P over A, 10%, 14 right parenthesis, multiplied by left parenthesis P over F, 10%, 1 right parenthesis, and multiplied by left parenthesis A over P, 10%, 15 right parenthesis, equals 651,000 yuan. AC sub A is greater than AC sub B. Scheme B is better than Scheme A, so Scheme B should be chosen. Next, let's learn about the net present value (NPV) method. When using the NPV method to evaluate mutually exclusive schemes with different lifespans, it's important to note that the NPVs of the schemes over their respective lifespans are not comparable in time. Therefore, a common analysis period needs to be set. Common methods for setting the analysis period include the least common multiple (LCM) method and the study period method. Let's first learn about the least common multiple method. The least common multiple method, also known as the scheme repetition method, sets the common analysis period as the least common multiple of the calculation periods of the alternative schemes. It assumes that each scheme repeats within such a common calculation period, meaning that after the end of its calculation period, each alternative scheme continues to cycle with the exact same series of cash flows as in its original calculation period until the common analysis period ends. Based on this, the NPV, or present value of costs, PVC, for each scheme is calculated. Evaluation criterion: the best scheme is the one with an NPV greater than or equal to 0 and the highest NPV, or the one with the lowest PVC. For example, if there are two mutually exclusive schemes, A and B, with calculation periods of 4 years and 6 years, respectively, their common calculation period would be 12 years. It is then assumed that Scheme A will be implemented 3 times, and Scheme B 2 times, with their net cash flows being recalculated accordingly. The NPV or PVC for each scheme within the common calculation period is calculated, and the best scheme is the one with an NPV greater than or equal to 0 and the highest NPV, or the one with the lowest PVC. Let's understand the least common multiple LCM method through an example. A scheme has 2 mutually exclusive options, A and B, with relevant data as shown in the table below. I sub C equals 12%. Use the net present value NPV method to select the best option. Option A, investment of 8 million yuan. Annual net income of 3.6 million yuan. Lifespan of 6 years. Option B, investment of 12 million yuan. Annual net income of 4.8 million yuan. Lifespan of 8 years. Analysis: since the lifespans of the 2 schemes are different, we must first find the least common multiple of their lifespans, which is 24 years. The cash flow diagram after repeating the 2 options is shown below. From the cash flow diagram, we can see that Scheme A is repeated 4 times, and Scheme B is repeated 3 times. Based on this analysis, we can compare the options by calculating the NPV for each. Solution: NPV sub A equals -800 multiplied by left parenthesis P over F, 12%, 6 right parenthesis, -800 multiplied by left parenthesis P over F, 12%, 12 right parenthesis, -800 multiplied by left parenthesis P over F, 12%, 18 right parenthesis, plus 360 multiplied by left parenthesis P over A, 12%, 24 right parenthesis, equals 12.877 million yuan. NPV sub B equals -1,200 multiplied by left parenthesis P over F, 12%, 8 right parenthesis, -1,200 multiplied by left parenthesis P over F, 12%, 16 right parenthesis, plus 480 multiplied by left parenthesis P over A, 12%, 24 right parenthesis, equals 18.561 million yuan, since NPV sub B is greater than NPV sub A. Scheme B is better than Scheme A, so Scheme B should be chosen. The above is the entire content of this video. Thank you all.